Today we get to look at Surds. This is Kisembo Academy, and thanks for tuning in. Now, before looking into Surds, we need to understand the difference between rational and irrational numbers. Now, to begin with, rational numbers are those which can be expressed in the form of P over Q. Now, P and Q are integers, as long as none of them is 0. And examples of integer numbers here we have 1 over 3, 36 over 1, 2.05 is equal to 205 over 100, and so on. Now these are rational numbers. Now the opposite of these are numbers that are irrational, and irrational numbers are simply those that cannot be expressed in this form. They cannot be expressed in form of fractions. In other words, irrational numbers are numbers that can't be expressed in fractional form. And some of these are shown here. We have the square root of 2, which is that, the square root of 3, which is that number, the third root of 70, which is that. Now looking at these numbers, there's something we see about them, that they are infinite and non-recurring decimals. Now, because they are infinite and some are non-recurring decimals, some are infinite, it becomes hard for you to easily locate the square root of 2, just like that, unless you use a calculator. So, numbers such as square roots, cube roots, which cannot be evaluated exactly, are better off left in this form, as you can see. So now, numbers that are left in this form because you cannot easily evaluate them are what we call surds. So this form is what we are calling the surds. Or in other words, I can say that a surd is any number of this form, of the square root of a, of square root of b, where a and b are any integer. So a surd is any number of that form which cannot be expressed as a rational number. So we are going to go on and look at how we simplify surds. In simplifying surds, we need to know some background knowledge about surds. In this illustration, in black ink, we have the square root of 4, multiply that by the square root of 16. We know that the square root of 4 is 2. The square root of 16 is 4. So 2 times 4 gives us 8. But at the same time, a square root of 4 times 16, if you first find the square root, you first find the product of these two numbers, which is 64. And you go ahead and find the square root of the product of those two numbers, it's still going to give you the same answer, which is 8. So it is either way, so this means, see, since when we found the square root of 4 separately and then the square root of 6, it gave us 8, and then we first multiplied these two again to get one number, then we still got the same number of 8. It simply means that square root of 4 multiply that by square root of 16 is the same as square root of 64. And this kind of analysis brings us to a conclusion as this. The conclusion it brings us to is that square root of a times square root of b is the same as square root of a times b combined. We need to commit this to memory. Also, we get to look at another illustration here. We are having 4. Square root of 4, multiply that by square root of 4 gives us the square root of 16. And when we find the square root of 16, our answer is 4. We were dealing with the same figure and it gave us square root of 4. Likewise, square root of 5, multiply that by square root of 5 gave us square root of 25. And we know that the square root of 25 is 5. So when we multiplied the square root of the same number twice, we got the same number. So this also brings us to another conclusion. For example, if I have square root of 100 times square root of 100, the answer I expect here is 100. If I'm having the square root of 20, multiply that by the square root of 20, I should be able to get 20 as the answer. If I'm having the square root of 1,000, multiply that by the square root of 1,000, it brings us the answer to 1,000. This is the conclusion these two illustrations bring us. And in general terms, square root of x, multiply that by square root of x should be able to give us the answer as x. So with that brief background information, now let's get on to simplifying these surds. Now in the simplification of these surds, in most cases we are always given an entire surd, like such as this one, root of 24. And we are supposed to simplify this square root of 24. Now, in the process of simplification of this square root of 24, we need to first split this number into its factors. Now, one of the factors that we choose, because now if you look at this 24, we have factors such as 2 times 12, 2 times 12 gives us 24. Then we have 3 times 8 can give us 24. Then we have 4 times 6. It can still give us also 24. So we choose 2 factors, but one of those factors should be able to give us a direct square root that is known. So in this case, 24 is going to, when we choose 4 and 6, 4 times 6 gives us 24. We find that we can easily get the square root of 4, which is 2. So square root of 4 times 6 means it's going to be the square root of 4 times the square root of 6. Now, of course, we know the square root of 4 can easily be gotten. It is 2. But we do not know the square root of 6. It is an irrational number. So we leave it in surd form. So it means that our final answer is going to be 2 times the square root of 6. Now, this 2 times the square root of 6 is what we are calling a mixed surd. Why are we calling it a mixed surd? Because it is a product of a rational number and an irrational number. So in other words, a mixed surd is a product of a rational number and a surd. So we always convert an entire surd to make a mixed surd in the process of simplifying surds. And this is something that we shall always encounter a lot in our calculations. So we'll go straight ahead and try and simplify some surds for illustration purposes. Right here we are having the square root of 99. So to simplify that surd, we are supposed to identify 2 factors of 99, but one of those factors should be able to give us a direct square root. So here, this is the same as saying the square root of 9 times 11, because 9 times 11 is 99. But we know this is the same as the square root of 9 times the square root of 11. And we know the square root of 9 is 3, so it's 3 times the square root of 11, which is not a direct, cannot easily be gotten. So we leave this in surd form because we do not know it directly. We need to play punch calculation. It's an irrational number. So the final answer is going to be here 3 root of 11. And this is the simplification of that entire surd. This is what we're calling a mixed surd. Going on to our second example, square root of 50 is going to be the square root of 2 times 25. That's going to be, this is the same as the square root of 2 times the square root of 25. And of course, the square root of 2 is an irrational number, so we leave this in surd form as square root of 2. Multiply that by the square root of 25, which is known, which is 5. So the answer here is going to be 5 times the square root of 2. So 5 root 2 becomes our mixed surd, and it is the simplification of this entire surd. To continue to simplify these surds, if you look at this, we have 4 times the square root of 72. Now, this looks like it is a simplified surd, but it is actually not, because why? The number under the square root sign can still be simplified further. When we are simplifying surds, we are supposed to do it in such a way that the number under the square root sign cannot be simplified any further. So, in other words, a surd is said to be in its simplest form when the numbers under the square root sign have no perfect square. And of course, we all know the perfect squares we are talking about. We have like 1 is a perfect square because 1 squared is 1. We have 4 is a perfect square because 2 times 2 is 4. We have 9, which is a perfect square because 3 times 3 is 9. We have 16, we have 25. All those are perfect squares. So we are supposed to simplify a number to a point whereby the number under the square root sign is not a perfect square. So 72 still can be simplified further. So to simplify, this is going to be 4 times, this is going to be the square root of, now for 72 can be simplified further into 36 times 2. And so this is going to become 44 times square root of 36 times square root of 2. So you realize that square root of 36 is 6. So it's going to be 4 times 6 times the square root of 2. And 4 6 are 24. So it's going to become 24 times root 2. And now this is the simplified form of that surd. 75x squared is going to become the square root of 75 times the square root of x squared. And of course here, square root of x squared, this square root goes with that, you remain with x times the square root of 75. That's the simplification of that side. Then we have two more numbers right here. We have 90a squared b squared. To simplify that side, we look for factors of 90. Which of the factors of 90 have a perfect square? We can have 2 times 45. We have 3 times 30. We have 5 times. We have 9 times 10. And 9 is a perfect square. So we are going to choose this and replace it with that. So this is the same as saying it's going to be the square root of 9 times 10. That's going to be times a squared times now b to the power 5. Now b to the power 5 is the same as b squared times b squared times b, like that. Let me rewrite this here. So now this is definitely the same as the square root of 9 times the square root of 10 times the square root of a squared times the square root of b squared times the square root of b squared times the square root of b. So this becomes now the square root of 9 is 3 times the square root of 10 remains as the root of 10 times a squared, which is the square root of a, times b squared, which is the square root of b, times b squared, which is the square root of b, the square root of b squared, which is b, then times the root of b. So this is going to be b, 3 times a times b, which is going to become 3ab squared times the square root of 10 times b, which is 10b. And that is the simplified form of this. So let's do this. 243. Let's find the factors of 243. Now the factors of 243, we have 3 times 81 to represent this. So this we take on these two factors. So we know that 243 is the same as 3 times 81. Now this is the same as the square root of 3 times the square root of 81. But we know that the square root of 3 is an irrational number, so we leave it as a surd. Multiply that by the square root of 81, which is 9. So it means that here our answer is 9 times the root of 3. And that is the simplification of that surd. So throughout our calculations, as far as surds are concerned, we shall always be required to simplify them, converting entire surds into mixed surds. This brings us to the end of this video. Thanks for tuning in. For more of these videos, I encourage you to subscribe, to share this video, and to hit that like button. For Kisembo Academy, this is Arnold Rangakuramia.